Today we will discuss manipulability ellipsoid, that is velocity ellipsoid, and force ellipsoid, the relation between them for given posture. We are considering two are planar robot with link L1 and L2. There are two joints, this one and this one. This one is movable joint, this one is stationary. For the sake of simplicity, we have considered L1, L2 both are 1, and the limited torque we are applying here and here in such a way tau 1 square plus tau 2 square, here torque square plus here torque square is 1. So under this condition and at that posture, at that initial position, this point has velocity ellipsoid, that is called manipulability ellipsoids, and this one force ellipsoids. Theta 1 equal to 0, theta 2 equal to pi by 4. See here, theta 1 is 0 with horizontal direction, and this is theta 2 which is pi by 4. So we will obtain the equation for this manipulability ellipsoid, that is velocity ellipsoids and force ellipsoids. See here, the mathematics behind it, x1 dot, x2 dot. This one is Vx, velocity in x direction, this one is velocity in y direction. For 2R planar robot, the general formula is minus L1 sin theta 1 minus L2 sin of theta 1 plus theta 2. And this second element, first row second element is minus L2 sin of theta 1 plus theta 2. Second row first element is L1 cos theta 1 plus L2 cos of theta 1 plus theta 2. And the second row second element is L2 cos of theta 1 plus theta 2 into theta 1 dot theta 2 dot. It is joint angular velocity. First joint, it is second joint angular velocity. This column, first column is J1 of theta, Jacobian. This second column is J2 of theta. So velocity of tip and effector is x1 dot, x2 dot. It is this one into this one. First row, this one. We get x component. This one into this one, we get y component. But as a whole, this is not x component. This is the velocity, tip velocity. If theta 2 dot is 0, and this is also as a whole, this vector is this. But this is not x component, this is not y component. This is the velocity of tip if theta 2 dot is 0, and this is velocity of tip if theta 1 dot is 0. But for our initial condition, theta 1 is 0 and theta 2 is pi by 4. So this Jacobian matrix is minus 1 by root 2 minus 1 by root 2. If we put theta 1 0, theta 2 pi by 4, we get this matrix 1 plus 1 by root 2, 1 by root 2 into theta 1 dot, theta 2 dot. So multiplying first row, this column, we get minus 1 by root 2 theta 1 dot minus 1 by root 2 theta 2 dot. And the second element 1 plus 1 by root 2 into, and the second element is 1 plus 1 by root 2 into theta 1 dot plus 1 by root 2 into theta 2 dot. So this is x component of its velocity, tip velocity, and this is y component of tip velocity. So Vx, which is equal to x1 dot, which is denoted as x1 dot, it is minus 1 by root 2 theta 1 dot minus 1 by root 2 theta 2 dot. And Vy is, which is denoted as x2 dot, it is 1 plus 1 by root 2 theta 1 dot plus 1 by root 2 theta 2 dot. Now we are eliminating theta 1 dot, theta 2 dot. So adding these two equations, this term cut out. So Vx plus Vy is, after cut out this term, Vx plus Vy is just theta 1 dot. You can add. And from this, if we put theta 1 dot in this equation, this value, we get 1 by root 2 theta 2 dot, subjecting 1 by root 2 theta 2 dot is minus Vx. This one here, minus Vx minus 1 by root 2 theta 1 dot from this equation. Subjecting 1 by root 2 theta 1 dot, we get minus Vx minus 1 by root 2 theta 1 dot. But theta 1 dot is this, Vx plus Vy. So theta 2 dot this one, initially multiplying root 2 both the sides, minus root 2 Vx minus theta 1 dot, minus bracket, so root 2 Vx and theta 1 dot plus theta 1 dot, but theta 1 dot is Vx plus Vy. So minus of root 2 plus 1 Vx plus Vy. This is theta 2 dot and this is theta 1 dot. This is theta 2 dot in terms of Vx Vy, and theta 1 dot is also in terms of Vx Vy. Now using the rule, term rule, but theta 1 dot square plus theta 2 dot square is 1. But theta 1 dot is Vx plus Vy whole square and theta 2 dot is this. So minus of root 2 plus 1 Vx plus Vy whole square, squaring this one, Vx square expanding this one, Vx square plus 2Vx Vy plus Vy square, plus here root 2 plus 1 whole square Vx square plus 2 into root 2 plus 1 Vx Vy plus Vy square, and 1 here minus 1 equal to 0. So expanding this and separating the terms, like terms, adding like terms, we have 1 plus root 2 plus 1 whole square into Vx square plus 2 plus 2 into root 2 plus 1 Vx Vy plus 2 Vy square minus 1 equal to 0. This one. So therefore 1 plus 2 plus 2 root 2 plus 1 Vx square, here 2 plus 2 root 2 plus 2 Vx Vy plus 2 Vy square minus 1 equal to 0. So this one is 1 plus 1 2, 2 plus 2 is 4, 4 plus 2 root 2 Vx square, here also plus 4 plus 2 root 2 Vx Vy plus 2 Vy square minus 1 equal to 0. It is an ellipse. Now f tip is the formula inverse of transpose of Jacobian matrix J of theta transpose minus 1 tau. J of theta we have already minus 1 by root 2 minus 1 by root 2 1 plus 1 by root 2 1 by root 2 transpose minus 1 tau 1 tau 2, and transpose of this row becomes column. So 1 minus 1 by root 2 minus 1 by root 2 1 plus 1 by root 2 1 by root 2. Then after we will take inverse in next step tau 1 tau 2. Inverse of this I have calculated roughly and put here 1 minus 1 plus root 2 1 minus 1 tau 1 tau 2. This one, this column, this row, this column, we get fx, and this we get fy, force x component of and y component of force. Now therefore f tip is 1 tau 1 minus 1 plus root 2 tau 2, and y component is tau 1 minus tau 2. So fx is this, fy is this. Now we want to eliminate tau 1 and tau 2. Adding this to subtracting these two, so minus cut out. So fx minus fy, here minus root 2 tau. So tau 2 is fx minus fy upon minus root 2, and so from this equation tau 1 is fy plus tau 2 equal to fy plus tau 2 is this, so fx minus fy upon minus root 2, taking LCM minus root 2 fy plus fx minus fy. So fx minus root 2 plus 1 into fy upon minus root 2. This is tau 1 and this is tau 2. So applying the condition, unit circle rule, but tau 1 square plus tau 2 square equal to 1. We have applied torque on both the joints satisfying this condition. So fx minus fy upon minus root 2 whole square plus fx minus root 2 plus 1 into fy upon minus root 2 whole square equal to 1. So simplifying, first multiplying 2 both the sides, because of minus root 2 square is 2. So fx square minus 2 fx fy plus fy square plus fx square minus 2 into root 2 plus 1 into fx fy plus squaring of these 2 plus 2 root 2 plus 1 into fy square, and here 2. Now simplifying this equation, 2 fx square fx fy term these 2, so minus 2 plus 2 root 2 plus 2 fx fy, and fy square this one. So 1 plus 3 plus 2 root 2 into fy square minus 2 equal to 0. So 2 fx square minus 4 plus 2 root 2 fx fy plus 4 plus 2 root 2 fy square minus 2. Dividing both the sides by 2, we get fx square minus 2 into bracket 2 plus 2 root 2 into fx fy plus 2 plus root 2 Fy square minus 1 equal to 0. It is also an ellipse, force ellipsoids. Okay. We are discussing 2R planar robot at initial posture theta 1 0 theta 2 pi by 4. This is maniability ellipsoids, that is velocity ellipsoids, and this is force ellipsoid, deep force ellipsoids. See, in this direction this is limited velocity, but in this direction force is greater, we can apply more force, and in this direction maximum velocity we can give in this direction, but in that direction we can apply less force, the reverse. As for the manipulability ellipsoid, a force ellipsoid can be drawn by mapping a unit circle iso effort. We have applied torque on this joint and this joint. This is movable joint, this is fixed joint, such that tau 1 square plus tau 2 square 1 iso effort contour in the tau 1 tau 2 plane to an ellipsoid in the F1 F2 tip force plane via the Jacobian transpose inverse J of theta raised to minus t, that is inverse of transpose of Jacobian. See above figure, this one. The force ellipsoid illustrates how easily the robot can generate forces in different directions. From this figure we can see that in this direction we can generate maximum force, but in this direction we can generate this much of force only, and in this direction we can generate least force. As is evident from the manipulability and force ellipsoids, if it is easy to generate a tip velocity in a given direction, then it is difficult to generate a force in that same direction, and vice versa. In fact, for a given robot configuration, the principal axis of the manipulability ellipsoids and force ellipsoid are aligned. See here, this axis and this axis are aligned. This axis and this axis are aligned. And the lengths of the principal semi-axis of the force ellipsoid are the reciprocals of the lengths of the principal semi-axis of the manipulability ellipsoids. See here, this one is shorter and this one is bigger. We know that reciprocal of small number is bigger one. Similarly, this one is bigger and this one is shorter, and we also know that the reciprocal of bigger number is smaller one. At a singularity, the manipulability ellipsoid collapses to a line segment. Suppose if we consider, see, this is 2R planar robot. In this position, this is the plane, and in this position theta 1 is also 0, theta 2 is also 0. So tip point can move in this direction only. It has freedom in this direction only. It cannot move for 2R plane, this plane robot, horizontal plane. It cannot move in this direction. At that instant, it can move in this or in this direction. So it is singularity. But in this direction the force is greater, but in this direction velocity is greater. So at a singularity, the manipulability ellipsoid collapses to a line segment. The force ellipsoid, on the other hand, becomes infinitely long in a direction orthogonal to the manipulability ellipsoid. See here, this one, and this one is longer force. In this direction shorter velocity, less velocity, but in this direction maximum force. Orthogonal to the manipulability ellipsoid line segment, that is the direction of the aligned links. This one, the force ellipsoid on the other hand becomes infinitely long in a direction orthogonal to the manipulability ellipsoid line segment. That is the direction of the aligned links, and skinny in the orthogonal direction. Consider, for example, carrying a heavy suitcase with your arm. It is much easier if your arms hang straight down under gravity with your elbow fully straightened at a singularity, because the force you must support passes directly through your joints and therefore requiring almost no torque about the joints, and only the joint structure, body structure bears the load, not the muscles generating torques. The manipulability ellipsoids loses dimension at a singularity and therefore its area drops to zero, but the force ellipsoid's area goes to infinity, assuming that joints can support the load. See here, suppose I am holding this bag with straight support, this joint with straight. So in this condition, I have applied maximum force, but I cannot move sideways. For this, if I want to hold this way, it requires more torque. Say here, muscle torque requires. But in this system, in this singularity state, minimum torque, negligible torque is required. But if I want to hold this way, it requires much more torque for using muscles.